All right. So, I mean, 2 classes ago, I was kind of going through how this communication was happening with this objective manager and this one objective that we have. There's like the mid level. The objective manager is like the highest level, just managing how your progress with the objectives in the game. Then we have this mid level manager who's kind of in charge of like collecting all these pickups. And here's like the lowest level, these pickup objects that have a collider, and ultimately they have this like on trigger method, and this is like where boom, the player touches it and that like fires it all off that something happened. But to begin with, they all have to like call each other. They all register with each other. All these pickups kind of go out to the objective class and register themselves with it. And then the objective manager, the objective goes out to the objective manager class and registers with them. So get used to that type of pattern, that like all this like registration and initialization at the beginning. Also, all this event calling is very common. And as you get more used to it, your code will look easier to read. This developer like understood the concepts, just didn't really execute them in a usable way. So you'll start to begin that when you write code, you're like writing code for the computer. And as the more you do it, you realize your code is more like meant for humans, for other people to read it. So you'll start to developing a coding style where it's like easy to read, and you're not. Sometimes also when coders first start out, they'll like learn new coding concepts and then want to execute them. It's like when you have a toolbox and you start to learn about hammers and screwdrivers. Just my son's a 4-year-old and he's gone through this, and you'll like pick a tool that's more elaborate than the job is needed just because it's a cool tool. It's something you just learned. But later on, you'll realize that's called over-engineering, and it makes your code harder to read. And every little technique and tip and concept you learn in programming, just like everything else, has its own place. And the more that you use it and gain experience, you kind of realize you'll pick the correct tool from your toolbox. So anyway, it's okay if sometimes the code is a little unclear or more complicated than you think it is, because you're going to run into that a lot. And it's also your chance, if you can try to simplify it, then that means you really understand what's happening with these objects. Ultimately, it just boils down to objects communicating with other objects. That's all object-oriented programming is. It's just breaking out your idea, your logic into objects, and how do you do that. So we've already kind of covered how the pickups are communicating with the objective, communicating with the objective manager. I'm actually over here, like notification HUD, objective HUD. So how are these? I have to pick everything apart. I kind of forgot. So we're in the game HUD here, and this here it's like at the game HUD level are all these managers, these UI managers. There's a lot. UIs are very complicated, and then you have to kind of drill down. And like here's the notification rectangle and the objectives rectangle. That's what these two are connected to. Notice notifications panel, objective panel. So I believe I think it was at the objective level that it was interacting. Yeah, I see a bunch of strings here. I think this is where it's connecting to the UI. Let me just take a quick look-see. This is calling update objective. Okay, so the base class objective, or the parent class of this objective reached target. I think this one that, yeah, okay. This one is registering here. So you see up here, notification HUD manager, objective HUD manager. So here on register, which is probably being called like on awake or something. two references. Okay, in this inherited class, you're calling register on start. Okay. So on register, go up to the objective manager and register yourself, this objective, and then go out and find me the objective HUD manager and the notification HUD manager. And this is just saying, if we don't find anything, we're going to have to handle an error. Like we can't run the game really, because then the UI is not going to connect up. But ultimately, what do? We go to the objective HUD manager and to the notification HUD manager, and we register this objective. All right, so in the objective HUD, register objective. And let me just see if it looks similar with notification HUD. No, it looks a little simpler over here. Okay, we start with the more complicated one, I guess. So I was kind of covering dictionaries last time, and I skipped this whole like pooling thing that was going on. So I'm gonna have to go into this. But remember, the dictionary is like a mapping, kind of like an enum, but you have to map a key to a value. And every time you create an element in this dictionary, you will need to define a key of type objective and a value of type objective toast. These toast meant like it's like a UI notification that's not meant to like pull your attention out of the gameplay. So anyway, this is the UI part. This is the objective part. On awake, we create the dictionary. And on register, the objective says, hello, UI manager. I am an objective. Will you register me? And so the objective comes in here. So this is called directly by, okay. You know what's interesting to talk about just quickly is that, remember I was kind of explaining the pickups to the objective manager. We're calling the classes, those static events that are on the class, and they didn't need to know about where these component objects, the objects of the classes were. And that was what I was saying was, it was kind of weird. They were calling event, which was then calling like a listener method. But ultimately, it was going down from class and finding the one object. So that's kind of called like a singleton. There's only like one object of objective manager, although the objectives, there could be more than one. But anyway, instead of having to like find the reference to the object, you call the class first, and the class can go, and the objects can communicate with its class level. So here we see another way. Here the objective needs to go out into the Unity scene and call this find object of type, and it will go through. And if you're searching for like there's a method where you can search for game objects by like names, layers, tags. Or this one is going to go through and look for component objects. So it's actually going to go through all these hierarchies of game objects and look through all their component objects and try to find a component that's of this type, objective HUD manager. So this is a rather expensive to do, so it kind of slows down your initialization a little bit. But this is actually going out and trying to find these object references that I was talking about. So this is... Yeah, it'll go through everything, and it'll return the first one or return null. There's also like find objects, and it'll give you the whole array of everything it finds. But this is hunting. It takes time. It's going to have to go through the whole Unity scene, and it's going to have to find this component object you're interested in. Or you have to go make like a public variable of that type, and then you kind of connect it up in the inspector. And that's why I was showing you that from pickup objects to objectives to objective managers, they were communicating through the class. And there's a benefit to that, is that you just don't have to do this object hunting around sometimes. But this is doing that other technique of hunting around and finding the objects. And that's why we're able to call the method right on the object and not the class. So anyway, this objective comes in, and it's actually going back to that objective, which has an action, and it's subscribing this. So on update objective, it's subscribing this method, which is on the UI manager, back to the objective and subscribes to it. So whatever, it's a little weird. We register with the UI manager, and then the UI manager says, okay, I'm going to go to your event and listen to you. But there's a reason for that. Is the UI wants to sit there and just wait for things to happen. Well, how does it know when things are going to happen, and it can like inform the player that something happened? Well, it has to listen to stuff. So for each objective, the objective HUD manager is going to listen to it. And so the objective over here, when things happen and certain things fire off, say a user touches on trigger on a pickup, and then that on pickup goes to its affiliated objective and says, hey, update yourself, something happened to me. And then the objective will invoke its event. It'll say, I've updated myself, and that's what this is. On update objective, ? Is anyone listening to this action? If so, I'm going to invoke the action with this data. What that really means is, hey, are there listeners? Go through each listener, which is really just a public method on another object, and send this data to it and let it do its own processing. So this objective object is firing off this event. There's really only one listener, which is the UI, this objective HUD. Maybe this guy's listening too, but this data, when the objective gets updated, there's a new description text, a new counter text, and a new notification text. So let's see where this is being fired. Oh, so they're right. They're listening. Never mind. They're listening. This method is called with this data, and then it invokes this event. So I'm sorry, who's calling update objective? So here we are. So objective reach target. So here, update objective. So this is when that pickup says, hey, you reached a checkpoint. That gets called. And then we figure out how many targets are remaining. And we call update objective. I'm not going to look at this one yet. Let's just look at this one. We're going to pass it an empty string. We're going to pass in get updated counter amount, which is here just return total pickup plus a string plus another string. And notification text, which is this thing right here, string notification text, is going to be this. So these are the three strings we're passing in. This is a ternary operator, remember? So this is going to equal, hey, what's this? Is this greater than or equal to that? If it's true, we're going to use that. Otherwise, we're going to use this. So all this comes back to here. Sorry. This gets passed into here, which is in the base class. And this event gets invoked, this action gets evoked, and we're listening on it over here because we registered ourselves. So this will get called. So we'll go through this in a minute, but that's the point of this right here. And now what's next? Instantiate the UI element for the new objective. So it looks like we have a UI elements per objective, and they probably get turned on and off visually as they get updated, and then probably fade out or something. But game object, UI objective plus instance. And is this objective optional? Which all of ours are mandatory, so it'd be false. So we would do this one. So primary objective prefab dot get object, and it's going to pass in true, and then the transform of this panel. So what is this? Primary objective prefab. So that's this thing here. So it's public. It was assigned in the inspector. It's going to be of type pool object definition. I'm just going to take a look at it here. It's this one here, primary objective. And if you click on it, it's got a little bit of a different icon. And when I click on them, they're called scriptable objects. And they're .asset. They're not like .c#, or this is something new. And notice it's actually coming from a script, this script. And I'm going to open it. And so this is a different type of script here. It's inheriting from scriptable object, not mono behavior. These aren't meant to live in your game. What you do with them is, once you write the script, I'm going to have to go through this script eventually, but somebody wrote this script, right? It's sitting right here. And then what you do is, I have to go hunt for it. Just give me a minute. Maybe it's under assets. Create. Okay. Yeah, so if you notice here, create asset menu, menu name, pool object. So this is a macro command. It's saying, hey, this thing is going to be named pool object definition, and the developer can access it under pool and object, under asset. So if we go to assets, create pool object. Okay, so this object here is the name of it, not this pool object definition. But what you end up creating is you create this. This is like an instance of it. It's an object, but it's an asset object. It's sitting in your assets. It's sitting on the file drive. It's not loaded into memory, into the hierarchy as a component object. Bless you. So it doesn't actually do anything at runtime. Now, it's actually really helpful. Programmers will create these so that designers can go in and notice there's all these like public like properties are exposed, and you can set them all. And so designers are going in and tweak this, and then other like component objects will reference this. So it's like exposing a lot of your code out, but in a designer-friendly way. So that's why they're called scriptable objects. So anyway, you create an instance. So it's kind of like this you can think of as like the class. And when you create an instance of it, an object, it's an asset. And they just sit there. They don't do anything. But the purpose of them is that you can tweak them, and then your component objects will reference them. So this is a pretty common technique in Unity development these days. So I'm going to delete this one because we already have one created. Scriptable objects. It's kind of hard for me to read. Let me do this. Objective toast primary. And so that's how it was created. Scriptable object. And these things have been set here. Ultimately, here is the prefab that we're going to mess around with. So this is like our pool. It's saying, hey, default spawn count. When the game first starts, we're going to spawn 2 prefabs of these. And something about make extra. I don't know. I'll read into this more. But let me go back to the scriptable object. Okay. So here's the publicly exposed stuff here. Public int, default spawn count. Here's a little tooltip. Spawn this many objects at the beginning of the game. Then int, make extra count. Spawn this many objects in one go if the pool runs out of available objects. And let me just return back to the idea of a pool. So object pooling. Destroying and creating objects like instantiate, like prefab.instantiate or like object.destroy is expensive. Adding stuff and removing stuff from memory at runtime is expensive. So what we prefer to do is pool stuff, meaning create a pool, many instances of one object and just turn them all off, and then we can turn them on and edit them and reuse them over and over again. Bullets from a gun is a very popular example in games. You're not going to create thousands of bullets. You could just cycle 20 or however many based on their shooting count.
So they're like all disabled or enabled at once?
No. There's just a pool of objects that you can grab from them. It'd be like, hey, you're gonna see in action a little bit. Like, hey, I need something in the pool. Say, I'm all my stuff's being used. Let me create a few more, and I'll give you one. Or, oh yeah, I have tons of stuff. Here, use this one. Turn it on, do what you want with it, and give it back to me when you're done. But let me just show you the example of it. So return to parent to reuse. So object parent must be returned to reuse. A false would be. So it's like object will be reused if disabled. It's basically like saying, do we disable the object or its parent when we're like reusing it? But it is turned off anyway, so it doesn't matter. So what is the pool object? What is the prefab, the actual game object that you will be creating, instantiating? And then these are private. So we have a list of game objects. This is our actual pool after we create stuff. And then the transform, like the parent. Like when you create game objects, where in your hierarchy, your scene hierarchy, are they going to live? So for us, we're creating stuff under here, the objectives rectangle, because these are objective UI elements. All right, so here we have some public methods that I'm not going to go into the details of them yet because somebody is calling them. Let's look at who's calling them. But there's get object, there's return all, destroy all, return object, initialize, and then some private, and then some type of enumerators here. So this is not a component object. There's not like on awake, on start. It just sits there waiting for component objects to do something to it. So where's the first time it seems like this is being, I haven't looked at other parts of the UI, but I'm just going to assume that this is the first time that this thing is called. So it's like saying, okay, we want a primary objective. We're going to call get object and true, and the objective panel is transform, which is this thing here. We're going to pass in this transform. All right. So whose primary object prefab is this? It's a pool object definition, and if I go to it, it's right here. It's this asset that was created from that class, right? So there's like an instance, one instance of this asset. This is the class. It's not doing anything, it's just a blueprint. Somebody created one asset object from it, this one right here. And where does it connect in our game? Well, the Objective Hub Manager component object is aware of it right here, right? And so it gets called right here, primary object prefab dot get object. So that's the first time something from, maybe other stuff is getting called on first. I haven't seen it yet, but this right here, get object. It's public, bool and transform. So if the application is not running, print out some error and just say return null, saying this is pointless. There's not even a game running. All right, so if the game is running, then we're going to create a game object variable, set it equal to null, and then we're going to loop through. So for entire, I think have I explained a for loop in detail? I think I have. But what's important here is pool.count. So if you come up here, we have a list of pool, and it's empty to begin with. And And so this loops through them, but it's empty. So there must be, this must be called, let me just see who's calling this initialize here. Okay, so there's this pool initializer up here. Okay. So somebody does call first. So up here in the game manager, I was wondering what this thing was. This pool initializer right here. Here's all of our pools. Notification, objective primary, objective secondary, win game message generic, time display, item, and which parent are we putting all this stuff under, I guess. So pool initializer. So make a public array of pools, pool object definitions, and then there's 6 of them. Somebody added these in the inspector. And then on enable here, probably, yeah. So on enable, when this component object is enabled, we call initialize, and here's initialize. So it just does this check. If this parent here is null, then you're transform on this component. But this is already filled out the game manager here, which is the same transform, doesn't matter. So what we're going to do is destroy all. So basically go through all these pools, and for each one, each pool object definition called destroy all in it, we're just going to clear out the pools in case something was left over. So this is probably used more when you're like switching game levels or something. It's like wiping out all this dynamic content, and let's spawn it. When you first create the game, this is not going to do anything because the pools haven't been created yet. But you can read through this. It goes through and just destroys everything that's in the pools. Once that's done, then we can loop through all the elements in our pools array up here. And since it's a one-line for loop, they didn't bother to include the semicolons. The curly brackets. When you just have one line, it'll just like execute it and just move on. But even with one line, you should probably just do your curly brackets. Anyway, for each element in pools, which is a pool object definition, call initialize on the parent. So that's what's happening here. So that's how we're getting this. This is actually happening. So assert not null. This is just doing like a safety check. but just saying, like, do you actually have prefabs that you have to? If this is null, then we have an issue. Then we need to like stop the game. But we do have prefabs associated with it. We have this one right here, objective toast primary. This is the game object, the prefab that will be instantiated. These are UI elements, so notice it's a rectangle transform, and then it has this script, objective toast. All right, so that's fine. We'll move through this line. We won't have an issue there. I see a chat. This could be wrong, but how do loops that iterate over a certain length work during runtime? If you're iterating over a constant, I assume it's simple in game development, but during simulation situations where you need to loop through a dynamic value, something like update, how do you approach that? Would you just use a different type of loop? Yeah, so there's for loops, and then there's while loops. So for loops is like usually going through a collection of stuff, and a while loop is like doing stuff, and then you keep tracking, like if this is true, should you continue? But these for loops are not. So even though the update loop is variable or dynamic, well, you're not looping through like the update loop. You're looping through something in the. I'm just trying to move to where there's a for loop. So let me just go back to pool initializer. So this is looping through this pools array, which is very common. It's right up here. This doesn't change. So if I go over to here, pool initializer. It's going through pools. There's 6 elements here, and there will always be 6 elements in this situation. So every time we loop through it, we will loop through 6 times. But no, there is situations where actually do it in my other class. So like when I'm deleting content, and I'll say, hey, here's a transform. Tell me how many children there are at this given instant. So, and just go through and like delete them all or turn them off. And with that update loop, so when that update loop, that update method is running, that code is running once per frame. That frame isn't like active when the update is running. The way that the frame works is all the code in the update must run, then the frame ends and a new frame begins, and then all the code is run again. So at that frame, it's like it's like a freeze. It's like you're freezing time right at that frame, and then you're running all your update code. So when you're looping through, let's just say we go into an update method call and we go into a for loop and say, hey, for as many children like that are underneath this game object, I want to delete them all. At that instant, at that like little frame, we freeze the time and then we loop through that. So at that little moment, when you're looping through it, you're looping through like a static size collection. You do have to be careful if you're like, say if I loop through the pools and I want to delete like each element as I'm moving through it, you have to be careful in like a list or something, because the list will like reorganize itself, and so I might point at something different. But you shouldn't be like deleting through a collection as you're like iterating through it. So there can be situations where like the collection is like dynamically changing as you're looping through it. But most of the time, that's not the case, and you should avoid those situations. And it's pretty like you don't need to be deleting stuff from a collection while you're looping through it. There's other ways to achieve that. Usually, you're like, if you do need to do that, you'll loop from the back. Like you'll give me the number, give me the element all the way at the end of a collection, delete it, and then subtract that number, move down, move to the next element, and so on. So this I changes. It starts at 0, and we increment it by 1, and we use that to like keep checking the next element in the collection. So anyway, this goes through and initializes each of these pool object definitions. And what it looks like it's doing is it's doing this populate group with the default spawn count, which in this case will be 2. So here's a while loop. So while need is greater than 0, and this comes in, it's going to be set to 2. We're going to instantiate a pool object, a prefab. Just remember, there's a big difference between this, a scriptable object, and this, the prefab that goes into the game. Goes in as a game object. So we're going to instantiate a pool object, give a reference to it. We're going to set its name to whatever the name property is. It's got to be around here. Whatever the current name is. So it's this objective toast primary. And then add an underscore, and then add the number. So in this case, when we start, the pool will be empty. So this will be a 0. And then if there's a parent, we do parenting under the transform component. So grab the game object transform component, call set parent, and this parent, which was the game manager. And then setting it false, there's world position. Yeah, just like don't change the world position of this object. And then we take whatever we created and we set the game object to false. Turn the game object off. And then add it. Add whatever we just created to our list. And then subtract this number. So 2 came in, now it's a 1. And is 1 greater than 0? Yes. So we loop through again. 1 becomes 0. 0 is not greater than 0. False. So we leave the while loop. We just created, instantiated 2 prefabs into as game objects, named them, and set them false, and put them into our pool list. All right, so that's called first. So now let me go back to here, the Objectives HUD Manager. And now it's going to call getObject on it. So on this pool scriptable object, we're going to call getObject. So right now we have a pool. We have 2 and they're turned off. Nobody's using them. So then this gets called with a true and whoever the parent is, that objective panel. So we just go through that, set this to null, and then we're going to loop through our pool. Now we have 2 elements in our pool, so the count is 2. I is 0. I is less than pool count, so true. So we go into our for loop. And then create a variable, set it equal to pool I, which is pool 0, the first element in the pool array. And if reference equals so where's this? Oh, it's an object. Okay. So if I hover over it, so this is coming from the object class. But anyway, reference equals. If one object equals another object, God, it's a much easier way of just, there is like an is. So they're checking if whatever we just pulled from the pool, if it's equal to null. So somehow like a null slipped in. This is a safety check. If somehow we pulled something from the pool and it equals a null, or if whatever we just pulled from the pool is active, it's already turned on, it's already in use, then we're saying, okay, continue. Continue means jump to the next iteration of the for loop. Like this one in the pool is no good. It's in use or it's nulled out. So we have to go find another one. So then we iterate I to 1, and we do the check again. And if it's good, if it's turned off, it's not null, then we can go on to here. So if return to parent to read, this was turned off. So pretty sure this was false. Yeah, this is turned off. So this is false. Doesn't matter what this is. False and true is still false. There's an and operator there. So we don't even do this. Wait, hold on a second. If this and this is not equal to this, what an annoying. So they're saying whatever this evaluates to, if it's not equal to this, get the instance ID of the object. So if the parents, every instance, so every object has like a unique ID to it that's hidden behind the scenes. So if the parent game object's ID is not equal to, get this instance, get its parent, get its ID. Okay, so these two are compared. So these two need to be false to be true because this is not equal to. So whatever the parent is of this object and of whatever we just this object's parent and whatever we just prefab we're referencing, those two need to be different for this to be true, and this needs to be true for us to say, nope, we're no good. But this will always be false right here because we set it to false right here, so I can just ignore this whole thing. So this check is just invalid.
Is there a case it would ever be true though, or?
But this would have to be turned on.
So it's like manually, not like with that.
Well, this would have to be turned on, and this would have to be true, which is saying wherever this pool object definition, wherever its parent get instance, whatever this instance value is, as long as it's not equal to this whatever prefab we grabbed. I don't know what they're checking for, but I don't even think this is a rare situation. Whatever. This would not be evaluated, so we're gone. And so object, this game object gets set to this, and we're good. We can break out. We don't need to keep looping through. We found something good in our pool that we're going to use, so we're good. We can move on. And then if reference equals, so they're doing a null check again. They're being very cautious. Okay, as long as that's weird. If reference equals whatever we have in null, then let me read this for a second. If pool count is 0, initialize null, else populate group. So I mean, whatever we have is not null, so this wouldn't be run. So I'm not sure why they're double checking for null again and what they're happening here, but I don't care because whatever we have is not null. So let's just move on. If the parent, if we have a parent that we're gonna want to set the parent to, which we are, it's the objective panel. It's this thing here. Then we're going to say, okay, whatever the prefab we have that we're coming from the pool, take its transform, set its parent to that. It's going to go there. And then turn it on, set active true, and then return it. Okay, finally we get through. Here's the object. We turned it on for you. We parented it for you. It's a valid thing, and we can get out of that. And then that's what this gets back. Here you go. Here's a reference to your prefab. That's what this is. So we're all the way back to Objective HUD Manager. After going through all that pool initializer and pool object definition and then the actual prefab that's associated with that. So if this is not optional, yep, it's mandatory. So whatever we just got, take its transform, set sibling index to 0. So if it's basically, if we have more than one objective messages here, make this thing, put it right to the top. It's a primary, it's a mandatory one, it's not objective. Let's make it show at the top of our UI. So it'd show up here instead of down here. And then whatever we have, get the component on it, the objective toast component. So if you remember what ultimately we're creating this thing. So let me just drag it in to here. Yeah, actually you could see it nice. So it gives a little element right here, UI element. And then it says go into this script right here, objective toast, go into this component. And get a reference to it, make sure it's not null, sure. And then call the initialize on it with the title, the description, the updated counter amount. Is it optional? What delay do we put? All that goes into this initialize. So here's our objective toast script. This is the little UI element that shows up. That's what this thing is right here. And initialize is called. Looks like this goes to the canvas. The UI canvas say force an update. I don't know. They don't want to wait till the next update frame, I guess. But get the rect transform, not a regular rectangle transform because it's UI. And we're going to set the text element to title text. We're going to call this set description text here. So this description text, this text gets set, and then turn on set active this subtitle rectangle if this string is not null. So here you can see there's a few different parts to it here. So this is the title text. Right now it says defeat all enemies, but you can pass in whatever you want. This is the main title of the message you're sending in. And then here's the description part. If there's like secondary information that comes in, it'll get filled in there. And if there is no secondary information, that's what that setting active means. It'll just turn off this second part. There is no description. There's just a title. Just turn that part off. All right. So that's what this setting the title text. This must come in. There must be a title, so we don't need to turn on and off. And set description. Set it and check if it's empty. Just turn the whole thing off. That game object, that part of it. And then counter text content. So that's this part here. 0 out of 5. 4 out of 5. How far are we along that objective? That part will get set. To me, that seems like it's part of the description, though. So I would just put it in here, keep the whole thing together, whatever. Layout rebuilder, force rebuild. So it's like I don't deal with this UI stuff that much, but what they're doing is they have these canvas groups. Like UIs are really annoying, and there's a lot of like components that are built for you to help you do like column layout, row layout, table layout. You could just like throw a bunch of gamma objects together and it'll like organize it really well for you. So that's with this like layout rebuilder. Like after you modify it and change the width and stuff based on turning stuff on and off, here, just go redo the layout of the UI. And then the fade in. So the time that we should fade in, the thing just doesn't pop on. You want it to look nice. It's going to animate on with opacity. So the fade in time is whatever the current time is since we've been running, plus this little delay. There must be a little delay around here somewhere. Oh, it comes in here. Float delay. Then start the fade in. Is fading in true? Is moving in true? So it looks like this update is always running when you create this thing. So it's saying, then this update is running. So it's like, okay, whatever the current time is, subtract out the start fade time, which was set up here when we first initialized it. So as this difference gets bigger, this number grows. Initially it's 0, but it starts getting bigger. And then if we're fading in and we're not fading out, then we can do this. So we are fading in right now. And so this, remember, it starts at 0 basically. Fade in duration is set up here, I'm guessing, half a second. So as long as 0 is less than half a second, when we first start, that's true. So then canvas group.alpha, which is this canvas group down here, and this is how we're controlling fade ups and fade downs. It's just going from 0 to 1 in a nice animated way. So this alpha is going to be 0 divided by half a second, or 0, invisible. And then, as this update, each frame passes, this number gets bigger. So let's say it's getting close to 0.5. So then like 0.4 over 0.5 or 80%, it's pretty opaque. Eventually this gets close to 1. This might be like 0.4999 over 0.5, or basically 1. And then that number gets bigger then. This number gets bigger than that number. And so we don't go into here anymore. And we go into here. We set the alpha to 1. And then we're done. Is fading in is false. And we play some type of sound. And since this is false, we don't come into here anymore in the next update loop. And so we're done with this part right now. And I think this animates too. I think we're doing a fade and we're like maybe moving up or moving sideways a little bit. So are we moving in? Yeah, we are moving in. That was set to true. This must be a point. Yeah, it's a 0.5 as well. So we're just moving the anchored position. The rect transformed anchored position, new vector 2. There's an x and a y. So move in curve on the x and the y stays the same. So what this is going to look like is this x position here. It's going to move like this, ever so slightly in. The y isn't animating. So how is the x animating? That's why it's a new vector 2, because we have to update this every frame, the x and the y. And the anchored position is a vector 2. And so what are we doing here? How are we, so the y is simple. Just keep the y, never change it. The x is saying take time since faded over moved in. So it's kind of the same here. To start off, it's 0 over 0.5 or 0. This starts growing and eventually gets close to 0.5. 0.5 over 0.5 is 1. So this is going from 0 to 1. So this is a move in curve dot evaluate. So this is pretty interesting. The move in curve, I think, was it up top here? Yeah, so these are like animation curves that you can create in the inspector. Super cool. So if I go up to it, public animation curve, they just declared a public animation curve. You called it something, and then you get this. So one way to do animation, animators and animation files. And then the animator is like a state machine, and it decides which animation it should be playing and what part of the animation it is in. The kind of the opposite approach is like procedural animation, doing it by code, start coroutine, enumerators, changing properties of component objects over time. And then this is another way. This is like the newer way, is offering up these animation curves, and then you evaluate at which part you are in the curve. So it's a little bit of mixture of the animation system, like the animation files, and a little bit of mixture of proceduralism. And it's like supposed to be a healthy balance of the two. And what you do is you say, hey, okay, this is an animation curve, evaluate. So you have to evaluate it from float time. It has to be from 0 to 1. Very similar to lerping in a coroutine. You must go from 0 to 1. You must go from A to B. How far are you from A to B? That is T. T maps from 0 to 1, or A to B. But that is a linear interpolation, which is this curve just without a curve. Linear. We are moving from A to B. In this case, it looks like negative 100 to 0 in linear steps. But a lot of times in animation, you don't want a lerp. You want something fancy or something customized. So now you have this curve editor, and you can place down points, and you can make a fancy, crazy animation curve that does whatever it is that you want it to do. And we can still interpolate over it from A to B, from 0 to 1, although it's not linear. Now we have this kind of crazy, fancy curve that we're going to interpolate the values over. And you get much better looking animations that way. So as we move from 0 to 1, we go, in this case, we're like kind of going linearly, and then we overshoot and we come back to our B. So negative 100, looks like we go up to like positive 15 and back to 0. So what does that mean? We start at negative 100, looks like around here, and we're fading up from 0. We're fading up from nothing, and we're moving this way, and then we get to like 15, and we kind of come back a little bit. Cool. So let me just hide this thing and let me just click play and let's see this animation. Hopefully I didn't break anything. So did you see it? Came from left to right and bounced back and it faded up at the same time. You just have to wait for like this play animate, this 3, 2, 1 animation. I'll just do it real quick one more time, zoomed up. 3, 2, 1, and fade up and pop in. Did you see the animation? Oh.
Would you say that using curves is a lot lends itself better to 3D animation as opposed to 2D?
Yeah, because 3D animation is, I mean, you're going to be using animation files which use these curves, but it's hard to express a 3D animation with just one curve. But yeah, it's just, there's many techniques. So you have the animation system, you have coroutines and lerping, and now you have evaluating curves from 0 to 1. It's just, again, more tools in your arsenal. But yeah, they can approach 2D animation well. So this is the fading, and here's the moving from left to right. And then if it fades out, like after a certain amount of time, it's going to sit there, and then it's going to do that move out. It's going to fade in a very similar way. It's going to fade down to 0. We're going to turn it off. While it's doing that, these are both true at the same time. We're fading out and moving out at the same time. And so we're evaluating this curve. This time it's going from right to left. All right. So this thing keeps running and keeps getting bigger. And eventually this thing must be made true. Or does somebody, let me see, maybe someone's setting it. Oh, on complete here, all this stuff. So who's calling this? Oh, when you unregister. I guess that objective sits up there, and eventually when it listens and it says, oh, we're done, I got an update from the objective, we're good to go, guys. Let's let's remove my listener from that event. Let's grab this thing out of my dictionary and call complete on it, and then remove this thing from my dictionary. So that's the end life. So this thing just stays up there, but eventually it gets unregistered. So we remove the listener, we go into the dictionary and grab the toast thing, call complete on the toast, and then just remove the whole thing from the dictionary. It is being removed out. Is there a script function for a nonlinear interpolation? Yeah, that's basically what the curve. That's what this thing basically is. Any type of curve that's not just a straight line is like nonlinear. So that's what this curve thing is meant to address. So now you can create nonlinear curves to evaluate from 0 to 1. There's a whole library of animation curves and what they're useful for. It's okay. This is from Unity, but what I really want is this thing right here. That's what. Can somebody just explain? Yeah, it's linear. Easing functions. That's what they're called. So this is used in like every type of UI from web to mobile to game. And then also in game animations, but using different ways to animate from A to B as opposed to just the linear approach. So all these different types of easings.
I've also seen those in like sound editing sometimes with volume manipulation and stuff.
I don't have much knowledge, but I do know they do those like envelopes to adjust But how do you start the animation? Well, here you go. This one's ease out. It's just how they move. So the whole principles of animation comes from Disney. It's all about giving a feeling of life and emotion to computer animation. Or back then, that was just hand drawn animation, like making it feel like there's momentum, weight, excitement, and stuff. And all UIs and game animations follow these principles of how stuff should move. So anyway, these are different type of. There are like animation, like you would call like a lerp. You could call like these equations too. You don't need to use like an animation curve. I've used other packages where you just like call these different curves instead of the linear curve. But Unity made it even more but here they are down here. Like if you don't want to manually create, if you don't want to drop points down and build your own curves, here's like the different easing curves. Not the entire amount, but a few of them. All right. So I'm going to stop the video here. Let me know if you have any questions.